Hello, and welcome back as we continue our discussion on AWS Analytic Services, this time focusing on Elastic MapReduce. So over here in the Orion papers, let's click on Elastic MapReduce, and then over here in the AWS console, we can find Elastic MapReduce under Analytics right here labeled as EMR. Now, as with some of the services that we've covered in the past few lessons, we do not have to know how to actually launch an EMR cluster and process data as part of being a solutions architect on the associates level. We just have to have a conceptual understanding of this service, what it does, and how it can be used. So with that, we're going to take a very high-level approach to understanding Elastic MapReduce. So first, let's click on EMR Essentials and just get a good understanding of what Elastic MapReduce is, and then we'll come back and talk about this diagram here. So Amazon Elastic MapReduce is a service which deploys out EC2 instances based off of the Hadoop Big Data Framework. So EMR is used to analyze and process vast amounts of data. So this is not only an analytics service, but also a big data service. We're going to be processing large amounts of data. EMR also supports other distributed frameworks such as Apache Spark, HBase, Presto, and Flink. So what is the general workflow of Elastic MapReduce? Well, data stored in S3, DynamoDB, or Redshift is sent to Elastic MapReduce. The data is then mapped to a cluster, what we'll call a Hadoop cluster, of master-slave nodes for processing. Computations, which are coded or created by a developer, are used to then process the data. So you actually now have to code what you want the Elastic MapReduce cluster to actually process and do to the data itself. The data is then reduced to a single output set of return information. And we're going to go into that process in more detail when we take a look at the attached diagram here. So what are some other important EMR facts that you need to know for the AWS CSA exam? Well, you, being the admin, has the ability to access the underlying operating system. So because this is a fleet of EC2 instances that we're deploying out to, you have access to the EC2 instances, to the underlying operating system running on the EC2 instances. So you can SSH into the EC2 instances if you wish, and you can make adjustments or changes to them at will. You can add user data to the EC2 instances launched into the cluster via bootstrapping. EMR also takes advantage of parallel processing for faster processing. So in this cluster, the more EC2 instances that we deploy out into our EMR cluster, the faster we will be able to process our data, because we'll be able to split that data up and have all of the various nodes, and we're going to talk about this in more detail in a second, but to have all these various nodes processing data at the same time. You can also resize a running cluster at any time, meaning you can launch more EC2 instances into it, so it's scalable, and you can deploy multiple clusters as well. So now that we have a good conceptual understanding of what Elastic MapReduce is, let's close out of here, and let's talk about some of the components and phases that make up Elastic MapReduce. So before we talk about the map phase and reduce phase, let's talk about the actual cluster itself. So the EMR cluster is made up of a combination of a master node and multiple slave nodes. However, before data starts to get processed by the master and slave nodes, first it has to have a source. So in this example, let's say that we have data which is sitting in an S3 bucket. When we launch our cluster, what we'll do is we will send data from the S3 bucket. So we have our data for processing here, which we pull into Elastic MapReduce, and then we're going to send it in to the EMR cluster. So first, let's talk about the master node. Now, the master node is a node that manages the cluster by running software components which coordinates the distribution of data and tasks among other slave nodes for processing. So we have all of these slave nodes, but it's the master node that is coordinating all of the work between all of these various slave nodes. And the master node tracks the status of tasks and monitors the health of the cluster. So in addition to just sending tasks to the slave nodes, it will also monitor the health of the slave nodes as well. Now, taking a look at the slave nodes themselves, there are two types of slave nodes. There are core nodes and there are task nodes. So for a core node, it is a slave node that has software components which run tasks and also stores data in the Hadoop distributed file system, HDFS, on the cluster. So these are the core nodes that do the heavy lifting with the actual data. Then there are task nodes, and this is a slave node that has software components which only run tasks. So these are nodes that only run tasks but do not store any of the data when it is in the EMR cluster. And task nodes are optional, but you do have to have core nodes as a part of your EMR cluster. So just to kind of recap on that, inside of the EMR cluster, we have a master node, which coordinates tasks and monitors the health of the slave nodes, and then the slave nodes themselves, which run the actual tasks, and depending on the node, being a core node, can actually stores data within the EMR cluster. Now let's talk about the map phase and the reduce phase. So first is the map phase, and this comes first in the process. And mapping is a function that defines the processes which splits the large data file for processing. So during the mapping phase, the data is split into 128 megabyte chunks. The larger the instance size used in our EMR cluster, the more chunks you can map and process at the same time. So obviously, the more data you want to process at any given time, the larger instance size you want, or the more nodes that you want. If there are more chunks than nodes or mappers available, then the chunks will queue for processing. So how does this mapping phase work? Well, remember, this is a function. So this is code that is written which tells the EMR cluster how to process the information. So let's use this example down below. Let's say that we have this set of data, and as a result, we want to get a count of each of these letters. So we want to have a total count of the amount of A's, and the amount of B's, the amount of C's, and the amount of R's. Well, the mapping phase, what that will do is take this data and it will split it up into equal chunks. So here we have 3 chunks with 3 letters each. That data will then be further organized as each node will run a task, and that task is to put a count to the number of times each letter appears in each one of these chunks. So as it was broken up here, there was 1 A in this chunk, there was 1 B in this chunk, and there's 1 R in this chunk. As down here, there was 1 A in this chunk, 1 C in this chunk, and 1 B in this chunk. So this is what happens during the mapping phase. We break the data up so that it can be processed in smaller parts. And obviously, the more nodes and mappers that you have, the more chunks you'd be able to process at the exact same time. So now moving on to the reduce phase. Reducing is a function that aggregates the split data back into one data source. So mapping, as in the MapReduce, so we're going to map first, and now we're going to reduce. So as we now look down at the second half of our diagram example here, what we see is we now have a shuffle and sort sections. This is where it's actually now going to sort all of our A's together, all of our B's together, all of our C's together, and all of our R's together. Then that information gets reduced down. So here we have 2 separate data sets indicating that we have 2 counts of A, but we want to reduce that into one data set, just saying, hey, for the letter A, we have a count of 2. For the letter B, we have a count of 2. For the letter C, we have a count of 3. And for the letter R, we have a count of 2. So just to kind of recap on that, we mapped the data out. We broke it out into various chunks for easier processing. It was then sorted, and then it was reduced back into one single file with all of the counts for each iteration of the letter that was in our original data set. Now, reduced data needs to be stored in a service like S3, as data processed by EMR clusters is not persistent. So once we're done processing and we shut down the EMR cluster, any data still in the cluster will be lost. So as we see here, the data from all the nodes is then reduced back into our processed data, and that processed data is then sent back to our S3 bucket, completing the life cycle and the circle of our data going through and being processed by Elastic MapReduce. So again, just some key items that you need to remember about Elastic MapReduce is that it uses the Hadoop framework to process data in a cluster made up of master and slave nodes. There are 2 phases: the mapping phase, which breaks up the data into 128 megabyte chunks for easier parallel processing. It is then processed based on the algorithms and the code provided by the developer, and then that information is reduced back into a single data set or a single file, and then stored back into something like S3, DynamoDB, or Redshift, wherever it is that you want that data to be stored. Now, you do have access to the underlying operating system, since All of these master and slave nodes are EC2 instances, and it is important to understand that data stored in the actual cluster itself does not persist past the life of the cluster. You need to make sure to save the processed data back into something like S3. So that is just a quick high-level overview of Elastic MapReduce, what its purpose is and how it is used. And with that, we will conclude this lesson. Thank you for watching. You may now move on.